Hey guys, we're going to talk about inequalities. Okay, so we're going to talk about inequalities. So we need to first know what the symbols mean. You've learned this a long time ago, but you may need to, just a little refresher. So you remember when you learned it in grade school, you probably learned it with like an alligator or a crocodile, sometimes Pac-Man. So the alligator eats the bigger number. But you really need to know what the symbol means and how to read it. Okay, so this is what I do. I hold my fingers up like this. This one is the L, okay? So it most resembles an L. So this would be less than, okay? So this would be less than. So again, your L, okay? The other way is, it's not an L, doesn't look like an L, so that's the difference. That's how I remember the difference between the two. This is actually greater than, so greater than. Okay, so again, less than, greater than. So this sign right here underneath, I think you all probably already know this, but that means less than or equal to. So when you're reading it, you say yada yada is less than or equal to something else. Okay, so less than or equal to. Okay, so it could be either equal to 3 or less than 3 as an answer, as a solution set. Okay, so this is greater than, or it can be equal to. Okay, so greater than or equal to. So, all right, so let's go over an example of how to solve an inequality. The great thing about this is we've already talked about how to solve equations, and it's the same thing. Okay, so I'm going to distribute in, okay, so I'm going to find my parentheses, and the term right outside my parentheses is -7. I'm going to distribute the -7 in. Okay, so draw my line, just makes it easier. So I have 5x and -9 that I did not touch, -7x. Negative times a positive is a negative. Be careful there. That's where most people go wrong. Okay, be careful. Then I'm going to combine my like terms because they're on the same side. Okay, that's why I like to draw this little line. Because they're on the same side, I can combine them. Okay, so 5 minus 7, or you can say 5 plus a -7. So either way, it's going to get you the same answer. So that's -2x minus 7. And then still the same sign, -9, okay? So greater than -9. I'm going to add 7 to both sides, okay? And this zeroes out. I get -2x greater than -2. All right, here's the only difference when you're solving an equation and an inequality, okay? When you divide, let me see. When you multiply or divide both sides by a negative, okay, so both sides by a negative, then you have to flip your sign. So I'm going to divide by a -2, okay? As soon as I do that, I flip my sign, okay? So I'm dividing by a -2 to both sides, so immediately I flip my sign, okay? So then you get x less than +1, okay? X is less than +1. Again, when you divide by a negative, both sides, you have to flip your inequality sign. All right, your next example, just kind of solving an inequality. All right, your example is just solving an inequality. I find my parentheses. My first step is to distribute. So I'm going to distribute the term that's outside of the parentheses, which in this case is a 4. So I'm going to take 4 times 6, which is 24, and 4 times +8 is a +32x. Okay, keep my sign the same. I didn't touch either of these terms, so I'm just going to bring it down. All right? I personally like to bring all my variables on this side and my numbers on this side, but whichever way you want to do it, that's fine. I've also seen where the people take the smaller x a term, so the smaller variable term, and move it over. So whatever you want to do is fine. I'll actually show you that way. So minus 5x, minus 5x. This zeroes out, I get negative 30 greater than 24 plus 27x. Okay, so I'm going to subtract 24 from both sides. This zeroes out. I get negative 54 greater than 27x. Okay, I'm going to divide by my coefficient, which is 27, and I get negative 2 greater than x. All right, so here's a big mess, because on the answer choices, when you're working a multiple choice problem, the variable won't be on this side most of the time. It'll say x, yada yada. So when you divide by a negative, you flip the sign, but also when you rewrite your inequality, you would then, if I flip these two, I then would have to flip the sign. Okay, so again, if I flip these two, I then would have to flip the sign. So your answer on a multiple choice answer would be x, so x and negative 2, I'm going to flip those two, and I'm also going to flip my sign. So instead of greater than, it's going to be less than. Okay? Sometimes you'll see when you have x, okay, so what does it mean? What does the answer choice mean? It says x greater than negative 2. Okay, so x. All right, so what does it mean? Okay, what does it mean when it says x is less than negative 2? Okay, well, let's think about it. It's telling me that to make this statement true, because you're always looking to make a statement true, I have to put a number in here that makes it true. So I need a number. X has to be less than 2. Okay, so if you saw it on a number line, okay, and you haven't done this in a while, so if you saw it on a number line, we'll say 0 is here, 1 is here, oh, negative 1 is here, negative 2 is here, and so forth. So if I were to be graphing this, I would do an open circle, okay, because there's no equal to underneath it. But I'm not worried about the graphing part, but you need to understand what it means. So x is less than negative 2, so negative 1 is not less than negative 2. So any answer this way would be less than negative 2, meaning negative 3 would make it true, negative 4 would make it true. And then you also sometimes will see an answer choice that says all real numbers less than negative 2. Okay, so that is the same thing as saying this right here. Okay, these are equivalent. This is the same as this. Sometimes you'll see an answer choice written this way, and sometimes you'll see an answer choice written that way.